Today we are going to look at factorization. Under factorization, let's take a look at a number like this: as plus a. We now realize that in this number as plus a, there is a number that is common to both as and a, and that number is a. So if I take out the number a, as I have done, and then open a bracket and divide the tens by that same number, I will now have a into the a here. We cancel this a, leaving it with s. A divided by a will give you 1. What we have done is called factorization. This element here, a, is the ACF of as plus a. And it is that ACF that we have used to multiply s plus a, which is put in a bracket. This process is called factorization. We shall now take a look at more examples on how to carry out factorization. We take the first example and example 1. We have here factorize 4a plus 3 squared minus 3a minus 2 squared. For us to factorize this, I want to remind us our solution. Recall that a squared minus b squared is called the difference of two squares, and this is equal to a minus b into a plus b. As a matter of fact, this is the factorization of a squared minus b squared. We will now apply this principle in factorizing the given question. So we now have 4a plus 3 all squared minus 3a minus 2 all squared. Taking this in bracket as your a, we will now write it as 4a plus 3. Then of course minus this other quantity as your b. Put it in bracket because of the minus sign here. 3a minus 2. Close this and then close the entire thing. Take it up again and write your 4a plus 3. This time plus this same quantity 3a minus 2. Close it. We may not need to open and close this bracket because the positive sign will not change any value there. Alright, so we simplify the first bracket. We have 4a plus 3 minus times this, minus times 3a will give you minus 3a, minus times minus will give you plus, and that is 2. Close that same bracket, open and close it. Then you also take this one, simplify it. 4a plus 3a is 7a, and 3 minus 2 is plus 1. You see, go ahead here. 4a minus 3a is a, and then plus 3 plus 2 is plus 5. And then of course what we have here is 7a plus 1. And this is the factorization of that expression. Example 2. You are asked to factorize 16 minus 3s minus y all squared. You have to factorize this expression. Your solution: you have your 16 minus 3s minus y all squared. You have to write your 16 as a square, and that means 4 raised to power 2, so 4 squared, minus 3s minus y, now also squared. So since both of them are squared, then we are looking at the difference of 2 squared, which becomes 4 minus 3s minus y. Make sure you put this in bracket, and then you have to put everything in bracket. Again, you take this, your 4, instead of minus now, becomes plus 3s minus y. You do not need to put this one in bracket because the positive sign, as I said earlier, will not affect anything there. So, what happens? You open the bracket inside this bracket, giving you 4 minus 3s minus y is plus y. And then here you have your 4 plus 3s minus y. Now let's see, is there anything we can do further than this? The answer is no. So that is the factorization of that expression. Another example would be something like this. You are asked to factorize 9 into s plus y all squared minus 4 into s minus y all squared. Okay, now if you look at this, the 9 here can be written as a square. So our solution, first of all, write 9 as 3 squared and is multiplying s plus y also squared. 4 can be written as 2 squared and it's also multiplying s minus y also squared. Now you realize that this can be written together. It means 3 into s plus y. Everything here is squared. Minus your 2 multiplying s minus y. Everything here also squared. Applying the difference of 2 squared, you now have 3 into s plus y, which is the a now, minus your 2 into s minus y. We close this, and this will be multiplied by the same 3 into s minus y, and then plus 2 into s minus y. We close that. So when we simplify the brackets, you have here 3s plus 3y minus 2s plus 2y. We close this bracket. And the same thing will happen here, 3s minus 3y, and then plus 2s minus 2y. Simplifying further, we will have 3s minus 2s is s, and then plus 3y plus 2y will give you plus 5y. You close that bracket, open another bracket. 3s plus 2s will give you 5s. And then minus 3y minus 2y will give you minus 5y. Now, observe something here. You discover that 5 is common in this last bracket. To bring out the 5, it becomes 5 multiplying s minus y, and then everything will be multiplied by s plus 5y. And this is the result of the factorization. Take note of that move, of where you now discover that this has to also be factorized to give us this. Another example 4. We have here factorize 12s squared minus 27y squared. Okay. If you look at this, your solution, 12 and 27 cannot be written as a square. It's not a perfect square. But we know that our 12s squared minus 27y squared can be written as 3 times 4 of s squared. That is, this is your 12 now. Minus 3 times your 9 and then y squared. This is your 27. You realize that in this group and in this group 3 is common, so you bring out the 3. You are now left with 4s squared here, and here you have 9y squared. Good. So what happens next? You can now write your 3. Your 4 can be written as 2 squared, and s is also squared. So these two are squared minus 3 squared and y squared. So this one again is squared. close the entire bracket. Observe that this becomes 3 into 2s minus 3y, close that, into 2s again plus 3y. That is the factorization of the expression. You recall that in the example that I have already solved for you, most of them are dealing with difference of 2 squares. So take note of them. And now let's look at this. This one says we should factorize completely. And the expression is 6s minus 5 minus s squared. Now, your solution, you can recognize this as a quadratic function because the highest power of s is 2. So if you write your 6s minus 5 minus s squared, recall the principles of factorization. If you compare this to your c, maybe plus bs and plus as squared, a standard quadratic function. Now, in that case, what we normally do is your a, the coefficient of s squared, will be multiplying c, and then you will now be able to factor ac to give you the sum as 6, which is the middle term. Now, what am I saying? I will now take my a, which is minus 1, multiply it by my c, which is minus 5, and that is the constant term. I'm taking my a and my c, which is the constant term. Now, the product of this is equal to 5. Minus times minus is plus. I will now take the factors of 5 that will give me 6. So 5 and 1. 5 and 1. Because 5 plus 1 is equal to 6. So I will replace the value I have, the 6s, by 5 plus 1. So I will have here 5s plus 1s minus 5 minus s squared. Now let's see what happened here. As far as this case is concerned, we can rearrange this to have 5s minus 5 plus 1s minus s squared. So you can now pair this and this. Our 5 is common, s minus 1 is there, and then our plus s is common here, and you have here 1 minus s. Now if you take a look at this very critically, you can write this as 5s minus 1, and then revise the order here by introducing the minus s, and then this becomes s, and then minus 1. So this value and this value are not equal. And minus s times s is minus s squared. Minus s times minus 1 is plus s. So we have not changed anything. Nothing is altered. These and these are common, so you write s minus 1, and then what remains is 5, and then minus s. And this is the factorization of this expression. We can also rearrange these terms in such a way that we have a minus s squared plus 6s and a minus 5. And of course, the coefficient of s squared is minus 1. The constant term is minus 5. And if you find their product, it will give you the plus 5. Then we'll find the two factors of 5. When you add them, they will give you plus 6. So 1 and 5. 1 can divide 5, 5 can divide 5, 1. 1 plus 5 is equal to 6. So we can now write minus s squared, and then we have plus 5s and then plus 1s and then minus 5. In this case, we can rearrange because let's take this and see where we can have a common factor. This one will give you the minus s is common. Here will now be s. This plus now becomes minus and 5 will be there. Then over here, a plus 1 is common. Where there is no visible factor that is common, 1 is always a factor of every term. So we take the 1 and we have s minus 5. To see this now, you can see that we have s minus 5 and then we have minus s plus 1, which can be written as 1 minus s. Again, that factorizes the expression. So whichever way you look at it, you can rearrange it in the standard form and you carry on with your factorization. Factorize 9 minus s squared minus 3s minus 1 all squared. Now, our solution, your 9 can be written as 3 raised to the power 2 minus your s squared minus 3s minus 1 all squared. Now, applying the difference of 2 squared, this is 3 minus, open the bracket, you have your s squared minus 3s minus 1. Then close this bracket, open another bracket, you have 3 plus, open the bracket, s squared minus 3s minus 1, and that is it. Now, we can bring this out to become 3 minus s squared plus 3s minus is plus 1. Close that. You have 3 plus s squared minus 3s minus 1. Close that. You will now simplify everything inside the bracket, and that gives you 3 plus 1 is 4. So we have minus s squared plus 3s plus 4. Over here we have s squared minus 3s plus 2. Next is to factorize what is inside here. As you can see, this is minus the coefficient of s squared is minus 1. The constant term here is 4. And of course, minus 1 plus 4 is equal to 3. So we can rewrite this one as minus s squared minus 1s plus 4s plus 4. And the first one. In the second case, you have s squared minus 1s minus 2s plus 2. So what happens next? You can group this, just pair them. And if you pair this with that, what is common is minus s, remaining s plus 1. Usually I like students writing 1s so that they don't go ahead to say the many 0 there. Many of us do make that mistake from experience. So that is why I've written 1s. So when you take away the s, the 1 remains. Instead of you assuming that 0 is what remains. Next is this one, which is plus 4 into s plus 1. You close this bracket. Next is this. We have s here into our s minus 1. Then you have minus 2 into s minus 1. Close the bracket. Inside this 1, s plus 1 is common. You take that. What remains is minus s plus 4, which is written as 4 minus s. You take that. S minus 1 is common here. And then what remains is s minus 2. And this stands for the result, which is the factorization of that expression. Number 7. Find the factors of 4s squared minus 9y squared plus 20s plus 25. Solution. This type of problem you need to rearrange. And this rearrangement is as follows. You have 4s squared plus 20s plus 25, then minus 9y squared. You need to write this one as a square, as a perfect square. And how do we do that? Bring out the 4, and you have here s squared plus 5s plus 25 all over 4. Then minus 9y squared. Now that will give you 4. You will now factorize this one, and this becomes s plus 5 all over 2 all squared minus 9y squared. If you factorize it, you will get this. Now, this actually means 4s into 2s plus 5 all over 2 all squared minus your 9y squared. 2 is squared, so it becomes 4 into 2s plus 5, and when 2 is squared, it's now over 4 minus 9y squared. So that this 4 will cancel this. You are now left with 2s plus 5 all squared minus 9y squared. And this 9 can be written as 3 squared, therefore everything here becomes 3y whole squared. So we have been able to put it as a difference of 2 squared. The final answer therefore is 2s plus 5 minus 3y, and then into 2s plus 5 plus 3y, applying the difference of 2 squared. You can rearrange this to have 2s minus 3y plus 5, and then you have 2s plus 3y also plus 5. And this is the factorization of that expression. We have the exercise for today. Question number 1. Factorize 1 minus a minus b all squared. You have the options a, b, c, and d. Question number 2. Factorize 16s squared minus 1 minus y squared. You also have your options a, b, c, and d. Question number 3. Factorize completely 3 minus 12s squared. Your options are a, b, c, and d. The answer is among these options. Question number 4. Factorize completely s squared plus s all squared minus 2s plus 2 all squared. Options A, B, C to D is also given to you. Question number 5. Factorize completely 2t squared plus t minus 15. And you also have the options accordingly. Question number 6. Factorize abs squared plus 6y minus 3as minus 2bys. I give you a hint here. Regroup if the first grouping does not have a common factor. You have options A, B, C, D, where the answer lies. Question number 7. You have y cubed minus 4sy plus sy cubed minus 4y. The options are A, B, C, and D. Here are the answers to the exercise. The question number 1, option B. Number 2, option A. Number 3, option C. Number 4, option D. 5 is B. This is A and 7 is D.